All right. Let's try and get this thing running. Yes. Okay. Good morning, everybody. Thank you very much for the kind introduction. Thanks for having me. I spoke at Kodiak's in Cluj a few years ago. Feels like a century ago, but very happy to go back tomorrow as well. And happy to be in Bucharest for the first edition. So my name is Julien. I work for a startup called Hugging Face. I'm based in Paris, although I mostly spend my time on airplanes right now. So in this talk, I'd like to show you that machine learning doesn't have to be boring, complicated, and time-consuming. So I don't know about hyperproductive. Maybe I went a little too far here, as usual. But I want to show you that there's a way to do machine learning in a matter of hours, not in a matter of weeks, and not in a matter of months. So to understand, what we're trying to fix, maybe we should look at how things are working or not working today. And deep learning, which I'm sure you're quite familiar with, started in the enterprise world about around 2015, let's say, maybe a few years before, with the resurrection of very old technology called neural networks, right? Technologies from the 40s and the 50s, brought back to life with the availability of cheap compute and large data sets. And so companies starting applying deep learning to natural language processing and computer vision and speech and a whole bunch of different problems using a variety of neural network architectures. Okay? And a lot of times they would have to design those networks themselves, or they would try to, which, as you can imagine, is difficult and challenging and risky. But I guess the main problem was building data sets, right? If you speak with machine learning engineers and data scientists, they'll tell you they spend 50 to 80% of their time finding data, preparing data, cleaning data, labeling data. And deep learning needs a lot of data, right? And that's painful because generally when you work on machine learning, you want to work on machine learning, not on writing SQL queries or Spark jobs or labeling data, etc. And it takes a crazy amount of time, and it slows you down. So that portion of the project is useful work, I guess, but what you really want to see is a model that works. And until you have built your data set, you're not going to see that. So once you have a neural network and a data set, you need to train it. And people have been doing that on GPUs. And GPUs applied to neural networks is actually what made deep learning possible. It was good to see that GPUs could be used for something else than 3D gaming. There's nothing wrong with that. But GPUs, especially in the last few years, have been expensive, difficult to come by. For a while, it was pretty much impossible to buy, the high-end stuff. You could get them on the cloud, but if you wanted to buy that stuff for yourself, it was impossible. So now with the crypto crash, you can buy GPUs by the ton, but I'm not sure that's a good thing. And the biggest problem to me was the level of expertise required to do that stuff. If you try to do deep learning, let's say from 2015 to 2020, something like that, you would work with TensorFlow or PyTorch or other tools, which are amazing tools, but they require a very deep understanding of machine learning and the deep learning process and how the neural networks function or dysfunction sometimes. And generally, you would need a solid background in computer science, statistics, etc. And to me, that's a problem because, of course, we need the experts to advance the state of the art. But if we want every company out there to implement machine learning and deep learning in their applications and services, we need developers to be able to do that stuff. And I mean application developers, not machine learning PhDs. So that's the picture. A lot of companies are trying to do this. A lot of companies are failing to do this. And I guess that's what we're trying to solve. So I'm calling it deep learning 2.0. Maybe it's 1.1. Maybe it's 1.01. We'll see. But we see a new way of addressing deep learning use cases. And the first big change, obviously, is the rise of transformer models. Since 2018, with the launch of the Google BERT model, which I'm sure you've heard about, the first transformer model to achieve state-of-the-art benchmarks on NLP workloads. But then, lots of new models popped up for NLP and computer vision and speech, et cetera, et cetera. So we see this new architecture becoming a de facto standard for deep learning workloads. And this is good news, actually. We'll see why in a few minutes. The age of building huge data sets and labeling huge data sets is probably coming to an end for, I would say, at least enterprise customers, because we can use a technique called transfer learning. So transfer learning, in a nutshell, means you can work with pre-trained, off-the-shelf models that have been trained by experts on huge data sets. Think, Wikipedia, even bigger. And so they've been trained on a variety of tasks, and you can just grab those models, load them, try them on your own data, and a lot of times they will work just fine. Think, translation models or speech-to-text models. Generally they work fine for your problem. So you're done, right? You can just grab that problem and use that initial training and apply it to your own data. If you have very domain-specific data, let's say you work in chemical engineering or genomics, you have crazy vocabulary, crazy jargon that those base models might not pick up perfectly well. So that's okay. You can train a little bit more. It's called fine-tuning. And it will require some data, of course, but generally the amount of data and the effort required to do this is 10x to 100x less than the alternative, which is, hey, let's build a TensorFlow model and train from scratch on 1 million labeled images or something. Okay, so that's a huge time saver, and you can get to POC much quicker. So GPUs are still around, of course, and they keep evolving, but we have more options also. We see companies building machine learning hardware that's been specifically designed to accelerate machine learning, whether it's training or inference. So companies like GraphCore, Habana Labs, which is part of Intel now. Intel themselves are doing a lot of work on optimizing inference on CPU. And of course, the ONNX project, which is a huge project involving, I guess, 100 companies on accelerating models. So that's good news, because we have more options, and we can find the cost-performance ratio that works best for everybody. And finally, and again, that's the most important thing to me, we have developer tools. So we have tools that anyone can use, even if they don't have a machine learning background, right? And of course, we're going to see some examples. So that's how things are looking today. So I'm not saying deep learning 1.0 needs to go to the trash can, but if you're still doing 1.0 and have never looked at what I call 2.0, I think you're missing out, and you may be, making your life or your machine learning life a little more difficult than it needs to be. So transformer models, like I said, have been around since 2018, but we see an acceleration in adoption and dominance. And I think it's really fair to say transformers are eating deep learning for breakfast, lunch, and dinner these days. So the traditional architectures like convolutional neural networks or LSTMs or RNNs, which have proven successful, in the 90s and early in the 2000s, are slowly fading away, because not a week goes by without a new transformer model popping up and just improving on the state-of-the-art benchmarks. So again, from NLP to computer vision to speech, we see the transformer architecture becoming a general purpose solution as mentioned in the State of AI report, right? And the Kaggle Data Science Survey, the latest one, 2022, came out maybe 2 weeks ago. And as expected, it shows continued adoption of the transformer architecture by the machine learning community. So it's just, the Kaggle data science respondents, they had about 25,000 answers to that study. So I think it's kind of significant. And if you ask me, I think that number is kind of on the low side, based on the people I meet. But what's interesting in this, upwards trajectory in adopting transformers. And the latest State of AI report also came out maybe a month ago. And this shows the modalities for transformer research papers. So 2 years ago, you could see 81% was NLP, right? So people could really put an equal sign between transformers and NLP. Computer vision was only 2%. Now, you can see the difference. So, of course, NLP is still the larger part, 41%, but it's actually less than the half of the use cases. And computer vision has exploded from 2% to 22%, right? So again, from NLP to computer vision to audio and speech and even other use cases, multimodal data sets and use case and models, we really see transformers proving how valuable they are over the spectrum of use cases. And it's not just research papers and Kaggle users. Transformer models have been in production at scale for a while now. Google is using transformers for Google Search since 2019, so that's not bad. Our good friend Elon is using transformers for autonomous driving. Maybe he can use them to fix Twitter, I don't know. We'll see. That would be quite an achievement. All the voice assistants, Alexa and the other ones are using transformers for natural language processing and speech to text and other tasks. And you have also actual companies like Pinterest using transformers for recommendation, JP Morgan, and generally all of the financial service industry using transformers for NLP, computer vision, etc. And at Hugging Face, we work with customers across the spectrum, from life sciences to financial services to manufacturing to media and everyone in between. So it's really out there. So when it comes to Hugging Face, so we're a private company, and we're the stewards of open source projects. The most popular one being the Transformers library, which lets you work with those transformer models in just a few lines of code, as you will see. And as it turns out, this Transformers library is one of the fastest growing projects in open source history. And I know that sounds very bold, but it's a fact. If you look at GitHub stars here, obviously we're the blue line on the left. And we have been growing, and we are still growing faster than pretty much anything out there, including super nice projects like Keras, PyTorch, Spark, etc., etc. And we're even growing faster than Kubernetes, which I find mind-blowing, given the fact that everybody seems to be in love with Kubernetes these days. So this goes to show the machine learning community and generally the open source community is supporting Hugging Face, is using Hugging Face, and we see no immediate end or slowdown to this blue line, and that's fine. That's the way we like it. So in addition to the open source libraries, we build the Hugging Face Hub, which is our main website. And as you said, Vlad, people call it the GitHub of machine learning. I think it's a fair analogy because just like you go to GitHub to find code and share code for your projects, you go to Hugging Face to find models and data sets and share them. So It's a reasonably good analogy. I stopped updating that screenshot because the numbers are never up to date. So as of yesterday, I think, we have 85,000 models. We add about 500 models a day at the moment. We have 13,000 data sets. We have 10,000 organizations, from Google to Microsoft to Facebook to NVIDIA and research labs and universities, open source projects, and of course individual developers sharing their models on the hub. Day in, day out, we have over 100,000 active users, and we have way more than 1 million downloads every day. I need to update that one because I know it's much more than that right now. So a lot of adoption, a lot of traction, a lot of downloads, a lot of activity. That's the way we like it. So here's an example. Here's why I think people come to us, because we make it simple, right? So here's an example of classifying text with zero-shot classification model. So you all know text classification. Give a piece of text, score it with some labels, right? Zero-shot means you can pass any list of labels. You can pass anything, okay? You don't have to use labels that are in the data set. So that's a really cool technique. I like it. So of course that stuff is crazy complicated, right? And if you wanted to dive into the blood and guts of the Facebook model that I'm using here, you could do that. But honestly, I don't care so much. I just want to get the job done, right? So using the transformers library, I am importing a pipeline object which lets me create a classifier in one line of code with that Facebook model, but I could use any one of the thousands of classification models on the hub. Give it a long sentence from Wikipedia, give it some labels that I picked, okay? And again, I could pick anything here, and just score that sentence, okay? So if you're a machine learning engineer, right now you're thinking, okay, yeah, I know what's going on under the hood. If you're just a developer, or if you're not even technical, you don't need to know what's going on under the hood, right? All you need to know is 3 lines of Python, and you can add, I guess, state-of-the-art text classification to your application, right? With open source models in 1 minute, just like that. So that's kind of the vanilla transformer example. But like I said, it's not just NLP, so all the craziness these days is around the text-to-image models, specifically those stable diffusion models, right, where you give a sentence and it generates images. So you would think, wow, how difficult is that, right? It's got to be insane. And probably you've played with those models on the web. Well, we created a new library called diffusers, which let me create a pipeline in a similar way. I'm using a stable diffusion model here. Give it a prompt, and generate the image and save the image, right? And no one here would call this machine learning. It's beginner level Python, which is why I can write it. And this is the image it's generated, right? And you can try it. And if you think, oh yeah, okay, that's a curated example, it generated 1,000 images and it took the best one, you'll have to trust me that I didn't. I just ran this prompt maybe 2-3 times and picked the one that I liked best, okay? And it's not perfect, but for 5 seconds of GPU time, I think it's good enough. And it could totally fool people. And what I think is interesting is it picked up every single element in my sentence. This looks like the desert. This looks like sundown. It's definitely not, midday. You can see the sky is really more of a, let's say, early morning or late evening sky. And yeah, all the elements are there, right? So that's pretty nice, right? We can grab those. It doesn't get much more state-of-the-art when you think about transformer models, and yet just 2 lines of Python get the job done.
One question?
Yes, sure.
Go back. If instead of a Corvette you put a Mustang, have you tried it?
Yeah, you could try it, yeah. Oh, you can. I actually try. If you put a 70s Corvette, it will actually put a 70s Corvette.
If you put a horse or a cow.
I'm sorry?
If you put a Mustang, will you put a cow or a horse?
No, you get a Mustang. No, it knows what a Mustang is. Because if you say a Mustang parked,
If you don't put part,
you could get both. I'm pretty sure you're going to get horses and you're going to get cars. But if you ask me to draw a Mustang in front of an old school diner, are you asking about a horse or are you asking about a car? I don't know, right? Both work.
it's in the desert, could be both. I don't know.
Yeah, it could be both. So,
What desert?
but yeah, you can go and try it. So, trying to show you the family picture of Hugging Face right now. So on the right-hand side, you have data sets and models, like I said, and we have a set of open source libraries that let you work with them. So the Transformers library, which we'll look a little more at, the Accelerate library, which lets you do multi-GPU, multi-TPU training, etc. Diffusers for those text-to-image models, and other libraries. Spaces is very interesting. Spaces is a way to host your machine learning models in a simple web application on the Hugging Face infrastructure, so that you can showcase your models in action, right, inside a proper app and not just in a Jupyter notebook. So if you want to show machine learning demos to, let's say, business stakeholders or customers, I'm guessing they want to see a real app and not a Jupyter notebook. So spaces are insanely popular. And finally, we have inference services, and the latest one we launched is called Inference Endpoints, where you can, in a few clicks, deploy any model from the hub to your AWS account or your Azure account with different levels of security. We'll look at that. Okay? And last but not least, we have partnerships with AWS on SageMaker to train and deploy models there, and with Azure, where you can deploy models on the Hugging Face endpoints for Azure. Okay, so that's where we are today. So let's take a look. Let's take a look at a quick demo. So yeah, here we are. So this is a model that I fine-tuned. It's an image classification model that I fine-tuned with AutoTrain or AutoML service. So no code. On a data set called Food 101, right? And Food 101 is exactly what you think. It's a data set with 101 classes of different types of food, right? And it has 1,000 images per class. So it's a reasonably interesting data set, right? So I trained this model, fine-tuned it, so now, obviously, if I go to the model page on the Hugging Face Hub and I try to predict an image, it's going to load the model and it's going to predict it, right? So image classification, very simple, right? And hopefully I have Wi-Fi. Yes, model is loading, thank you. Okay? So all this took is a few clicks in AutoTrain, select my data set, select the task type, image classification, train the model for maybe an hour or two, and get a high-quality model. Accuracy is 91.5%. I didn't write any code for this. Okay. So let's wait to say baklava, hopefully. Let's see. Yes, okay, fair enough. So it's one of the classes in the data set, so no surprise. Now, what if I go out of domain and I try, bœuf bourguignon, which is kind of one of the staples of French gastronomy. Not totally unlike goulash, but I'm thinking just a little bit better, okay? So if I try to predict it, it's going to say steak, which is not awfully wrong because it's still a beef recipe, but it's not steak, right? And the rest is just pretty wrong as well. So you could say, well, okay, that's an easy problem to solve. Why don't we go to Google and scrape 1,000 images of bœuf bourguignon, which I'm sure all you French people have on the web, and I can add them to the data set and train again, and now I have 102 classes, and I could predict that. And you could absolutely do that. Or you could be very lazy, which I love to do, and you could say, why don't we try yes, that's the one. Right? Why don't we try and generate those images? Okay? So we could go to a space, whoops, we could go to a space for the latest diffusion model, and I could say, can you generate that stuff for me, please? And is it able to do that? Let's find out. Okay, it's not too bad. I mean, if you showed that to me, I would probably say, yeah, this looks like Boeuf Bourguignon to me, right? So instead of scraping those images, I can generate them, right? And the benefit is obviously, I can control the output a little bit more, and I could just launch that stuff and come back in an hour and get my images. And if I wanted to add 100 classes, like the top 100 Romanian, favorite food types, this is easy to do, no scraping, right? Just generate the images. And hopefully it could do all of that. So this is what I'm going to do, right? I'm going to load my stable diffusion model from the Hugging Face hub, okay? And then I'm going to create a pipeline and generate those images. And here on this GPU, I can do 4 at a time. So if I want to do, let's say, 1,000 images, I need to iterate 250 times, okay? So we could try that. And I can go fancy with the prompt. I could say a meal of Boeuf Bourguignon with a side order, either pasta, potatoes, or rice, maybe a glass of red wine and bread. Let's give it some input. Let's give it some freedom to generate stuff. Okay? So here I'm going to generate 8 images just to see what they look like, see if that prompt works. Okay. All right, that's a good one. Whoops, sorry. Although you would not put pasta like that, but okay. This is interesting. Bread, ask for bread. There's bread in this one. There's a glass of wine in this one. Okay, bread, wine. And you can see the diversity here. I mean, these look like real images, right? Okay, so it looks like I can do this. So I could go and generate 1,000 of those. It would actually take 1 hour on this particular GPU, okay, which is manageable. And then once you've done that, of course, I've got my images, and I can add them to my data set, right? Yeah, of course, this thing died. So I can go and, no, sorry. Here we are. I can go and add that new class to my data set. So now I have food 102, I guess. All right, okay, so 102 classes. I've got my new Boeuf Bourguignon class in there. Each folder has 1,000 images. And I can rebuild the data set just like that. The data sets library from Hugging Face makes it very simple. Just load those images from the folder. And I can push it to the hub in one line of code, right? And so now I've got my own data set updated on the hub, right? Start to see what our productivity thing comes in. A lot of stuff is one line of code, right? And if it's 2 lines, we try to make it 1. Because no one really likes to write code. I don't, right? And it should be simple. So now I have this new data set, and I can train again. So I could use auto-train, right? Just run that process again, click, 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 wait for 1 hour or 2, get my model. Or I could use the transformers library, so I won't go into the details too much because this is more of an intro level session, but what it really means is, load my initial model from the hub, right? The 101 classes model, and just train it again on 102 classes with the new data set, okay? And this is really what it takes. Some training arguments, batch size, number of epochs, okay? No PyTorch insanity, very simple generic code. You can see this is not even image classification specific. You could copy-paste the code and use it for text classification or audio classification. It would pretty much work the same. And then just train, passing the model and the data sets, et cetera, et cetera. Okay, that's the transformers library. And this is why this thing has 74,000 stars on GitHub, because it's simple. And it doesn't require you to learn all the details of PyTorch and TensorFlow. Okay? Then we go and train. Okay, so I trained this for just one epoch. Took about 30 minutes on this GPU, right? And I can push the model to the hub. Okay, again. So automatically now I have my new model. Okay, and all this stuff is created automatically for me. And by the way, these are Git repositories. So you can clone them with Git if you want to. You can manage versions, etc. And I can try it here. So why don't we try this image and see if it's predicted correctly now. Hopefully it is. Okay. So you can do this on the model page. But of course, at the end of the day, you want a real model in production. Okay, so that's where the inference endpoints come. And deploying an endpoint is really not difficult. You just go and select your model from the hub. Whoops. Yep. You decide if you want to deploy it on AWS and Azure, or Azure, and which region. If you want to deploy on CPU or GPU. And this is a few weeks old. So those bigger GPUs are coming very soon. You can set up auto-scaling, just like that. And you can decide which security level you want. So public means public, wide open to the world. Protected means open to the world with token authentication. And private means not accessible from the internet. And you can only access it through your own AWS or Azure account. We set that up for you. Okay? So I created that endpoint. Took a few minutes. And it's live here. Okay? And now, if we check that page, did it predict it? Yes, it did predict it correctly. So that's good. So now if I come to my local machine, I can just load an image. Okay? And I can just, using my token, because this is a protected endpoint, I can just send an HTTP query to the endpoint and predict the result. Right? Oh, this is a bit slow because I'm using my phone here. I'm not using Wi-Fi. But this is a very fast prediction normally. Okay? And I can see my prediction is fine. Right? So there you go. So here I took some shortcuts in the interest of time, but really, how much time does that take in real life? Training the baseline model with auto-train, let's say 2 hours. Generating new samples, let's say 30 minutes per class, right? And it's just a single GPU instance. If I had a bigger instance, it'd be faster. Training again, fine-tuning again, let's say maybe an hour if you want to do a couple of epochs. Deploying, a few minutes. So this means, in less than half a day, you can go full cycle from here's the problem I want to solve, here's my baseline model, I run some tests, not good enough, generate some data, fine-tune, deploy, test again, 3-4 hours, right? I don't think you can go faster with anything else, honestly. And here I'm using synthetic data, but if you had your own data, it'd be the same, right? It would be the same. So that's pretty much what I wanted to show you. So now it's up to you, right? So if you want to get started, if you're completely new to this, I would highly recommend that you go to those 3 pages. So the tasks page, which shows you, which explains to you in plain English, really in plain English, what those different task types are. Okay, so I guess image classification is simple enough, but if you're not too sure what image segmentation or zero-shot classification or all the other crazy things are, our DevRel team will explain it in plain English. If you want to get your hands dirty with transformers, we have a course online, which is developer-focused, not expert-focused. So you'll be running code on the first page, I guess, and starting with the pipeline and then going down to crazier models and generally learning a lot about the transformers library and the datasets library. And of course, you can go and check out the libraries on GitHub and install them and run a lot of the examples that we have there. Okay. If you want to stay in touch, while Twitter is still up, I'm there. You can find me on Medium, and I have lots of videos on YouTube as well on all those different building blocks that you saw on the Hugging Face family picture. And if you're interested in, I would say, commercial support, of course, we can help you get from, hey, we have this crazy idea, can we get it done? To, oh, wow, it's running in production in as fast as you can go. So if you're a startup, probably a few weeks. If you're a bigger company and you have security teams and compliance teams and a purchase department and so on, maybe a few months. But we'll go as fast as you can go, and generally will save you a lot of time. Okay, and we can do private deployments as well if you have very strict issues that and regulations that prevent you from running on a public website like we are. Okay. Well, that's really it for me. So once again, thank you very much for inviting me. Thank you, Vlad. And looking forward to Cluj tomorrow. Thank you very much for showing up. We have a few more minutes for questions. So let's do questions, and thank you very much again. Don't be shy. Yes, come on.
What's the traction of Hugging Face in Romania, or at least Eastern Europe? Is it widespread here?
It's everywhere. So it's a good question, actually. So the company is remote first. So we have employees pretty much all over. Not sure if we have employees in Romania. I have to say I didn't check, so apologies to my colleagues if they're here. But we see global traction when we look at the users. It's literally everywhere and in every vertical. So I don't have any specific Romanian example to give. But if you look, for example, at we have Romanian languages, Romanian language models. Sorry. So if we go here, we could check. That's generally a good sign. So where is that? Romanian, there we go. Okay, so we have Romanian language models, 278. So you can go and start from there, right? Including some really good ones. It's not, these are really good models. So that's a good sign. It means maybe Google, has added Romanian, because a lot of those models are multilingual. So Google or whoever has added Romanian as a language. So if they do that, it means they have users. And some other models are probably contributed by other users here in Romania who took models that didn't know how to speak Romanian and trained them on Romanian language. So that's a good sign. 285. So if you have 2878. So we need more.
Thank you.
Counting on you guys.
Why a company like Facebook will share their model on the Hugging Face platform? Because I was thinking that maybe they want to keep for themselves the model if they discover a good one.
That's a really good question. So machine learning by design is an open field because a lot of that stuff comes from research. And researchers want to publish papers. It's what they like. It's what they need for their career, okay? So they need to publish. So generally they publish the paper and they share models or at least weights. And that's what Google did with BERT in 2018, right? So by design, this stuff is open and the code is open source. Now, some companies have tried to lock it down. Not going to give any names. I have enough friends as it is. But the response to that has always been the same from the community. Oh, you're trying to close that model, put it behind an API and asking people to pay for that API? Well, guess what? We're going to build, in a few weeks or a few months, we're going to build an open alternative to this. And, Hugging Face led or co-led the Big Science project, which trained an alternative to a very well-known large NLP model that starts with GPT and ends with 3. And this is now available to the public, okay? Some company tried to close a very popular text-to-image model, and in a few weeks, the diffusions library and the stable diffusion models were available for everybody. So I think that's a strong sign that if you're trying to have gated models, black box models, than just APIs, the community will react to that. So Facebook initially was kind of on the fence, but I think they're clever and they understood that, and they do so much work in open source anyway, that they had to go that way. And they actually shared those OPT models that you probably saw that are really, really great, right? And really large language models. And Google is doing the same, and other companies are doing the same. So I'm not saying we're not going to see attempts to close things, but the reaction should be, oh well, you can do that, and we'll build something better on the side and share it with everybody. So, and Facebook is they have a ton of models on the hub, right? 407 models. So we thank them for that, and we're looking forward to more. But that's a really good point.
Have you entered in any data ethics type of conversations behind those models?
Yeah, that's a very good question. So we're trying to promote responsible AI. And if you look at a lot of those models, at least the ones that we actively maintain, you'll see on this model page information on limitations and bias and potential risks. We have a dedicated team working on this. We have Meg Mitchell, who kind of founded Ethical AI or co-founded Ethical AI at Google, working for us now. And she has a team working specifically on that stuff. Just last week, we launched, let me see if I can find this. We added bias metrics to, here it is. We added bias metrics to our Evaluate library. Evaluate lets you score a model with a whatever data set on accuracy, F1 scores, et cetera, and we added metrics for toxicity, et cetera. So we're trying to be active there, and we're trying to be pragmatic, because it's very easy to be philosophical and political about those issues. My personal opinion is fine, but I'm not very interested in that. Go debate on Twitter, right? While it's there. I'm interested in actionable solutions. So how do I know that a model is potentially biased or dangerous? How do I know that the data set has, ugly content? And yeah, I really encourage you to read this post. It has some extremely interesting examples of the bad stuff you could find in data sets and models, generally related to gender, so it's good to know. Fixing it is, I guess, the next step. It's more difficult. How do you counterbalance that stuff? So that's still research and work in progress, but at least being aware of the potential risks is a good first step. So yes, it's very important to us. We want to bring that technology in a reasonably safe way. And the first step is you need to be aware of the risks. Last one? Come on, you get one more.
How can someone discover up-and-coming startups on Hugging Face? Is it a good place to see what's coming new?
That's a very good point. That's a very good point. So actually, as we have a lot of traffic and we're the de facto place to share models, we're seeing startups, but even developers, starting to make a name for themselves on the hub. You know, if you're a developer and you have a popular open source project on GitHub, or if you're a data scientist and you rank nicely on Kaggle, you're going to get job offers, right? You're going to get interest. And we're starting to see the same on the hub. You know, I saw the other day on Twitter, I saw a startup that shared, oh, wow, okay, we put this model on the hub and it's got this many downloads and it's like a top 10 model already, and it's amazing. So sure, if given the amount of traffic that we have, if you put a model, if you document it, if you create a space, a fun space that people want to try, yes, it's going to get some interest. And it's like, okay, who are those guys, right? Where does that model come from? So yeah, I think it's looking at popular models, popular spaces, is a good way to keep an eye on what's happening there. And of course, you have the big companies, but you have some I would say individual players. There's this guy. I'm sorry, I forgot his name. Is probably in the top spaces. Is training all kinds of diffusion models on Disney characters, and have you seen that one?
Is Hugging Face mostly used by big companies like Meta, like Google, or is it mostly like individual developers or startups?
It's both. It's a lot of individual developers, but we have some companies who use the hub as a tool for collaboration. Because here I'm focusing on the that's the guy, Nitro Sock. Yeah, you need to check him out. Him or her, I don't know. Right, so it's training diffusion models to generate characters based on particular universes. So it's training on images like that, right, which come from video games or anime, and you can generate. And that's as far as I know, that's a single person, that's an individual. And he's getting thousands and thousands of downloads for these models. So coming back to your question, we have companies using this privately. Okay, so here I'm focusing on the public stuff, models and data sets, but you can make your models and data sets private as well, right? So if I go to this one maybe, okay, it's public, but I can make it private. So that means only myself and people in my organization, which in this case would be Hugging Face, could access that. So your company could share you can share your models, your data sets, and make them invisible to the rest of the community. You can have private spaces. We have companies using that, using spaces as their de facto demo platform, and they make all of it private. So yeah, we start seeing that kind of usage. So that's pretty cool. Just like you have private repos on GitHub, right?
And how much is public versus private?
The huge majority is public. The huge majority is public because people want the models to be found, right? If you train those great models, you want them to be found. But sometimes you keep them private because you're still working on them, right? It's work in progress. You're not happy with the results, so you can iterate. Just like you would make your GitHub repo private, until you're happy, until all the unit tests run, and the doc is ready, and then you go and make it public. So it's the same workflow. But generally, yeah, people want to be found. All right. Well, thank you very much.